It's wonderful to see the tremendous progress that Bigelow Aerospace has made in the past decade. It gives me great pleasure to introduce once again Robert Bigelow to the platform to give this evening's keynote address.
This is my first time to this facility, and what a magnificent building this is. Extremely impressive, to say the least. I want to express thanks again to the National Space Society for this wonderful honor, the award that we have been given to us, and it's going to be highly treasured and is very, very much appreciated. I have some slides, and I know that the hour is getting on, and I'm told I have about 35 minutes. I have some slides that are going to cover 3 different areas, and I know that some of you are not familiar with the expandable systems. I will talk briefly about the asteroid mission and about something else that might be another destination, a far larger size spacecraft. Before I forget it, I also want to express thanks to Dianetics for hosting us on some terrific tours, and I really appreciate that, so my thanks to Tom and Steve and Tim. Thank you very much. May we have the first slide, please? For those of you in the back, I will read along here with you. The designation BA330 means that it's 330 cubic meters, and to put that into perspective, the International Space Station is 1,100 cubic meters. So this is about 30% of the size of the entire station. These are expandable systems. Our heritage is from the NASA program, TransHab, which we took over after their funding was cut. Initially, it was funded by Congress and promoted by NASA as a Mars habitat, or habitats that be used to venture to the planet. So I was enchanted and astounded with the technology and couldn't believe that NASA had been prevented from going forward with that. So that's when we took up the challenge of going on with this technology. As was mentioned earlier, we do have 2 spacecraft in orbit, Genesis 1 and Genesis 2, launched by the Russians in 2006 and 2007. These vessels are fully self-contained. They are sized to accommodate a crew of up to 6. In none of our scenarios do we actually have that great an occupancy, but at least we have that as margin if we need it. They're characterized by the fact that they are launched uninhabited in the nose cone of the rocket, and then they expand, and they have debris shields which provide better protection than the aluminum structures on the ISS modules do. And we also have, and that protection is not only from a ballistic standpoint, but a radiation standpoint. We enhance the radiation protection by flying 2.5 inches of water that is situated in water bags, flat water bags, that are attenuated to the interior scuff coat of the entire spacecraft. And by the time we do that, we've more than doubled the protection that any of the vessels on the International Space Station can provide. The next slide, please. As I said, these are fully self-contained. They do not require another spacecraft to provide electrical power or propulsion or life support. Each one is equipped with complete hygienic facilities, restroom facilities, ACS. We have 2 different kinds of propulsion systems on the fore and aft bulkheads or airlocks. In fact, one of the systems was made by Tim Pickens and his staff of a local company called Orion, which was purchased about 1.5 years ago by Dianetics. And we are very pleased to have that system as a major component of our spacecraft. And you can see there are 6 people configured in this particular this artist rendering. The crew quarters would be on this side, and that area is large enough to house 6 people in fairly large compartments. And actually, it's a webbing netting kind of structure. As you might imagine, everything is quite flexible and quite adjustable. Next slide, please. And this is an end-on view, just to give you a perspective of the interior size. Again, this is 3 times the volume of typical volume on the International Space Station module is about 110 cubic meters. One of these represents 3 times that volume. Yes, next slide, please. We are in the process of human trials for ECLSS, for life support systems. And we have a metal structure envelope that represents the exact same physical dimensions and size and shape of the expandable systems. It has 3 different decks inside, and so we are now locking down people for various durations to test out our life support equipment. If we have any volunteers in the audience, we'd be glad to put you through that process. Next slide, please. The propulsion systems, we have a traditional hydrazine propulsion system, and we have a water-based system where we compress oxygen and hydrogen and then light it, and essentially that is a replenishable system. So that the water, we fly a large amount of water, not only for radiation protection, but also as a consumable, both for propulsion and for human consumption. And that is reprocessed. We also process the internal atmosphere, the humidity within the spacecraft as well. Next slide, please. One of the other spacecraft that we will be producing is a docking node and propulsion bus. The docking node is a very important spacecraft to us because it provides a number of things. It provides the intersection to add on in a tinker-toy kind of fashion other geometries for stations. So you can attach these in a linear fashion, as you will see in a minute, or we can configure them in other kinds of geometries. And so those ports are very important. In addition, for EVA purposes, this is the EVA hatch on the docking node. We can accommodate CTVs or other expandable systems on the other ports. The primary mission of the node and propulsion bus is to attach itself. The bus itself the purpose is to attach the node to a habitable system. And then secondarily, the propulsion bus provides electrical power and prop to provide reboost to the habitat or to a larger group of habitats. The amount of prop that we have in hydrazine enables the 330 to be a chaser. So that if there is a disconnect and for some reason a malfunction in the bus to be able to push the node to successful docking, the 330 can also approach the node and try to accomplish that same task. Next slide, please. So we can fly these in single mode or dual modes, as they each are completely standalone spacecraft. Next slide, please. So this represents the intersection configuration. This can in a linear fashion. And of course, we're going nowhere without transportation. That's one of the things that we've had to do in our company for a long time, is throttle back and forth our own progress according to the progress of transportation. So we're really excited about what's currently going on with the success of the different companies, and with NASA's support at CCDev is absolutely crucial to our company, but more importantly, it's crucial to the United States of America. Next slide, please. We can accommodate different kinds of spacecraft as far as the taxis are concerned. to give you some idea of the frequency of traffic, which translates into the number of spacecraft that need to be manufactured and the number of rockets that it takes to lift them back and forth, and eventually translates into jobs. One of our modules requires in a minimal, in any of the scenarios we have a lot of different kinds of traffic depending upon the nature of the customer. But our minimum requirement is 4 flights a year for one module. We like to rotate out all crews every 90 days to increase the length of duration of the careers of astronauts and participants. So if we have 4 crew dockings, four taxis that we need per year, if we have 2 modules, we would need 8. If we had 10, we would need 40 separate launches per year, be they in an accumulation as a multiple station or in a onesie, twosie kind of fashion in a more singular kind of destination. NASA needs to have more destinations than what it presently has. NASA needs to have more targets for the CC dev companies to go after. It's not healthy if there is only the ISS as a destination. There are at least 4 viable companies that may succeed, and we all hope that they do. But they have to have adequate business to sustain them. The ISS alone isn't going to do it. It isn't going to sustain 3 companies. It won't sustain 2 if one of those 2 gets only 1 flight a year. And if that company is substantially based on a taxi service or a division of that company, that's not good. So we're trying we will have our first 2 BA330s ready for flight by the end of 2014. That may be a little premature when the taxi service is going to be there, but we want to be ready. And as we estimate it right now, we think that that's a fairly good guess that by 2015 we could actually be in service. At least that's what we're telling prospective clients. Next slide, please. The Olympus is a really exciting, fun kind of concept. We think we can do this. 2,100 cubic meters, almost twice the volume of the International Space Station. Crew of 16 is not mandatory, but it's a comfortable number, and we can accommodate 16 in this. What you see on the table there in the middle of the room is a 5-deck situation as to how we conceived some of the activities on board this kind of structure. Next slide, please. With 6 people inside, they kind of get lost. That's how big that structure is. It would take a super heavy to launch this. This is one of the best advocating kind of missions for a super heavy. And we'll talk about this some more. So it's almost 20 times the volume of the Destiny module and 7 times the interior volume of the 330. Next slide, please. Again, this just shows the interior area as to how it's broken up into different decks. The entire thing could be a hospital. We're very interested in medical attention, providing medical attention on orbit or a remote destination, how you execute surgeries, how you avoid being as invasive in surgery as you possibly can. You need the patient to recover fast, and you do not want to have a messy situation. And you also have to perform these surgeries if the doctor or doctors are incapacitated on board. So if you're 25 or 30 million miles out or worse, you're on your own. So all this needs to be practiced in LEO. Next slide, please. This is just a perspective of Olympus alongside 2 330s. This particular configuration is 2,760 cubic meters. We're starting to get now up into some sizable numbers. This would be launchable on a 70 metric ton super heavy. George Sowers of ULA says that they can modify a Delta IV into that launch capability, at least 70 tons, 70 metric tons. You've all seen this rendering before? When I first saw it, I was struck by some things that didn't seem to make sense to me. One is a violation of the fundamentals of safety, and that is there's no buddy system on this. You have one person out here on this asteroid, and this speaks that there are too few people involved in the mission on something so dangerous. The second thing that struck me is that I don't know how he or she gets out of the spacecraft. There's no EVA hatch. APAS is too small, even if they backed away from each other. You certainly aren't going to open the side hatch and expose everything inside one of the Orions to the vacuum. So I don't know how they do that. The more serious problem I had was the fact that for 2 people, for 6 months, it takes 4,500 pounds of consumables. And physically, there's not enough room to accommodate spacesuits, EVA backpack, 4,500 pounds of consumables, a toilet restroom kind of facility, which I doubt is probably very large. But you really don't have a chance of people surviving, I don't think, for 6 months on an Earth return mission. So what we did is we kind of came up with our own little scheme. Next slide, please. That's an expandable system attached to an Orion and its service module. And this is the AVA hatch, docked to the node, as I mentioned before. And this would be for a crew of 4, which provide a chance for people to be alive when they came back to Earth, even if it were a 6-month mission. But this is a mission that you probably only do one time. And that's not really what we're looking for as an industry. We're looking for missions that we can repeat and repeat and repeat and repeat, that have enough purpose to them that they make sense. So they are perpetual. They're not one-off situations. Next slide, please. Okay. So my point is, I feel that if we were to go back and look at the BA 2100, which is the Olympus spacecraft, to me that has a lot of purpose in creating a raison d'etre for a super heavy. I would like to see one of those in Leo. I'd like to see one in L1. And I would like to see one at about the 25 to 30 million mile mark as a destination. We haven't traveled very far at all from the shores of Earth, barely put a toe into space. So 25 to 30 million miles is a lot to us. It's not really all that far, but it is a serious distance in survival. At 25 million miles, a communication from Earth takes 2.25 minutes to be received. At 30 million, it's about 2.6 minutes before you receive it. You are really on your own. So that would be used as a way station, as a depot, a hospital, a rest stop, whatever, for future missions to Mars. And you might imagine that there would be other of those kinds of structures in some sort of linear fashion to where eventually they line up for a Mars mission, and you have those kinds of way stations. So those are some ideas. I think we, as a company, we definitely have ambitions to be participating in lunar activities or Mars activities. We'd love to partner with NASA or other companies in these kinds of activities. One of the speakers earlier mentioned a number of things that space was about. I frankly think there's one component that's been missing for 40 years. The '67 Space Treaty was necessary because of the circumstances. But I think the word ownership is missing also. Ownership is a tremendous driver for people to take inordinate risk with their lives and with their capital. And I think if you're going to create an environment of real ambition, that Article 16 needs to be used in the 67 Space Treaty, which is 2 sentences long, that essentially says, send in your notice of withdrawal and you no longer are a member. So whether it's helium-3 or other kinds of asset purposes, or just the prestige and psychological factor of being able to get back to the moon, it is very possible that when we do, we'll meet the Chinese there. The IMF, International Monetary Fund, is now predicting China will be at the same level or exceed the United States in GDP in 2016. A few months ago, I thought it would be about 10 or 12 years. So if you have the bucks, then you get the Buck Rogers. So anyway, I'm an advocate of free enterprise and ownership, because I think a lot of folks would be willing to take those kinds of risks if they have something more than just the experience to go after. That's my talk. Thank you very much. I was just informed that maybe someone had a question or two, and I'm certainly willing to answer anything that I can.
Did you know that the commercial human spaceflight program was coming, or did you find out like the rest of us?
Are you talking about the CC-DEV program?
Yes, yes. Did you know in advance, or did you find out the same way I did, in complete shock and happiness, I might add?
We have been trying for years to find ways to encourage and support that kind of an activity. Yes, we did know that something like that was coming, and COTS was the precursor to that, in a sense, in that really important partnership, even marriage, if you will, between NASA and the private sector. I think it's an excellent way for NASA to help reduce its costs and get more folks involved who are willing to take challenges and spend their own money. And I think together, really good things, exciting things can happen in the future.
What about the moon?
My personal opinion is Chinese are going to get there next in 2022, thereabouts. My personal concern that I've wrestled with for a year and a half is I think it's theirs for the taking. They are a member of the 67 Space Treaty, but again, it's very easy to opt out. If they went through the normal processes of surveying, they could actually lay claim physically to the property. The psychological impact would absolutely be hugely profound, not just for any Chinese person on the planet, but for everyone else besides. It would set them apart to actually own that body. It may take 5 or 6 years to execute that, but what makes it a perfect storm is you could never convince this Congress and this Senate that such a thing would have to be headed off, that it was going to be a reality. So by the time they got there and they started to perform that, it'd be too little too late. And they will acquire the technological capabilities. Chang'e 1, Chang'e 2, Chang'e 3 are all about that. Their regolith mission, return mission in 2017 is about that. Their influence globally. You don't kick sand in the face of a nation that's already as powerful as China is. It deserves an awful lot of respect, and they certainly have the ability as a country to maintain focus for a long period of time. That makes them very interesting in a 10 to 15 year time frame picture to me. So I really look for that probably to occur. If it were to occur, then I see Mars as being looked upon as a much more serious target in a different kind of way.
Are you, whoa.
Yes.
Are you satisfied at this point with the relationship that NASA has with the commercial sector? Do you have any suggestions for improvement in that relationship, or are things going about as well as they can right now?
It's been slow for a lot of us. It's been a slow process. I think the more dynamic a change is, the more difficult it is to undertake. Change always is a threat or a concern to certain folks, but I do believe that the administrator, Charlie, understands it. Lori really understands it. That's super important. The leadership of NASA is fully behind it. I see it's a win-win for NASA, win-win for the country, and I think, frankly, if we don't do it, we're going to be habitually trying to create partners with people overseas. Why not create the partners right here in America? Yes.
Well, we can, on the other hand, we can create partnerships with the Chinese as well. It seems to me that a program is highly derivative using Soyuz technology. What is the possibility of improving health amongst astronauts so that we can demonstrate a model of living in space as a model for living on Earth? For example, what do you have planned in the way of overcoming the problem of calcium and bone loss in space? There are currently programs in progress on the International Space Station, such as the ProK experiment, the investigation that will mitigate the problem of calcium loss significantly, and therefore demonstrate that the calcium loss that astronauts experience is the same as what we aging Americans, if I may say so, experience as well.
Yeah, they say that you lose about 1% a month of bone mass and muscle mass, and then it kind of plateaus. But I guess that is a different percentage, person by person, to some degree.
There are some astronauts who don't lose any.
Correct, and it's also mitigated by the amount of exercise that you do. So that's kind of an anomaly if you are in that group of folks that aren't seriously affected. But I think AG is important. I think for deep space missions, it's probably really very, very crucial. And if we get to fly larger and larger platforms, then AG is more and more possible. You don't want the Coriolis effect. So I'm an advocate for artificial gravity.
Actually, I was wondering about the use of agricultural habitats, because the ProK experiment demonstrates that nutritional countermeasures may largely ameliorate the problem of calcium loss by improved nutrition, by providing fresh vegetables
Yeah.
and sources of unprocessed food sources for the astronauts.
You're over my head. I haven't investigated that area, so I don't know.
You've got the habitats that will provide the capability.
Right.
Thank you.
Thank you. Any other questions?
Yes.
Yes.
How are you dealing with windows in the inflatable habitats?
As far as materials are concerned, we use a Lexan type of material. We have reasons for not getting into highly fine-tuned optical properties in that. The spacecraft would still be able to produce good optics, satisfactory optics that would be able to provide quite good optical resolution through the windows. I think exterior cameras, though, would be more practical. Genesis 1 and Genesis 2 flew 12 and 22 cameras respectively. So the airlocks on these spacecraft are quite large, so that would probably be one of the areas we'd look at for telescopic deployment for resolution of small areas on Earth. But we're flying at an altitude that's higher than your traditional spy satellites. We're at about 235 nautical miles, and that's not necessarily the purpose of our spacecraft. So we're focused on ballistic properties and on being able to cause repairs to be made, and also as to we on the BA330 we have 4 windows, but we can add and populate that spacecraft with more windows if we wish. That's what our test results, we have done an enormous amount of testing, and that's what it suggests to us. Well, and also thin screens inside with telescopic capabilities to bring the moon or Earth right up in your face and really essentially watch everything from inside on much larger screens.
I have a question.
Yes.
Yes, this is Andrew Sutenant, Director of Huntsville Space Professionals. We're very interested in commercial entities pursuing work in Huntsville. And what are your thoughts about expanding or developing offices in Huntsville, working with local entities? I know you're working with Dynetics.
You know, I'm missing part of that, please. Say that again, please.
This is Andrew Sutenant, Director of Huntsville Space Professionals.
Yes.
And we are an advocate, a nonprofit organization pursuing employment for, of course, all the professional scientists and engineers here in Huntsville, North Alabama. We believe that this location here provides the country with extreme capabilities that we cannot find anywhere else in this country. And we are highly interested in companies such as yours coming to Huntsville, such as SpaceX did last fall, and developing offices here to continue your research. And will you be pursuing such efforts soon?
Our best contribution to Alabama would be for a Super Heavy to be a reality, for us to partner with NASA in providing the Olympus spacecraft. We cannot manufacture that without having access, immediate access to a Super Heavy launch facility or to a waterway, to a river, where we would build that plant, let's suppose, in Huntsville, and we would barge that spacecraft to the launch facility. And that's a distinct possibility. If we had the opportunity, we would be all over that. Thank you.
Great, thank you.